All right, so what we're going to do is we're going to send in some bits over to our shift register. But first, let me just explain where these numbers are going to come from. All right, so you'll notice that normally we do the numbers as 1, 2, 4, 8, 16, like this way, where 1 will be over here and, 64 will be over here. Well, since we're sending in the numbers backward, we're actually going to, what do you call it? We're actually doing it reversed. It'll just make our life a little bit easier when we send the numbers in, because we're sending it in as most significant bit first, so the biggest number first. We're sending it in reverse. So we're just going to write the numbers in reverse. All right, just make our life easier. Otherwise, like, you have to do it and then flip it and it becomes annoying. Okay, now you'll see, notice you see common cathode and common anode. Let's look what we have. If we look here, you notice we have a common anode. It says common anode. So common anode is this column we're looking for. Common anode means this. When we put something to G is the decimal point, by the way, so we don't even have that on. Actually, G is the middle. Just kidding. G is the middle. That's 0. Okay, so that's off. So notice the zeros, when it's common anode, mean it's on. It's reverse. So zeros mean it's on, 1 means it's off. So if we want 0 on, we want A should be 0, B should be 0, Z should be 0, C should be 0, D should be 0, E should be 0, F should be 0, and G should be 1. That's good. If we wanted 1, let's see how they did 1. They put A as 1, so that's going to be off. B is 0, so that's going to be on. C is 0, that's going to be on. And then everything else off. Yep, that's right. So it'll just be these two, right? 2 would be, that would be 0 for A, 0 for B, 0 for G. So let's look. 0 for A, 0 for B, 0 for G, 0 for E, and 0 for D. So that's where these numbers are coming from, okay? Just so you know when I do these numbers. And the reason why we do it reverse and binary is because we're sending in the most significant bit first. So we're sending in the biggest bit first. If we were sending in the least significant bit first, we would just flip it and do it the other way, where we would put 64 over here, and it would be like that. But since A, we know, is hooked to A is controlling 1, B, like that. It makes our life easy if we write it that way. That's all. And G is like the 7th input in our shift register. So to get to G, we have to, what do you call it? We have to put in like a large number. And when we write it this way, that's the way the bits are going out. So the most significant bit first. It just makes our life a little bit easier when we know we're writing it in that way. So like, for example, if we write in like the one where only B and C is 0, that's this one. So we write in so that means only B and C are 0. So that means everything else will be off, but when it gets to B and C, it'll be 0, right? So that's the way it's working. Hopefully you understand how that works. So like 64 is 0, 121 is 1. That means if I add these up in binary, right? So how do I get 121? It's 64. Remember, we're going to only add up the zeros this time. It's reversed. So 64 plus 32. Well, you could do it this way because this one's even easier. So just 64. Boom. That's it. 1, 0. So this would be 1 plus 8. That's 9. Plus 16. Plus 32. Plus 64, which is 121. Okay, so that's where those numbers are coming from. So let me show you what to do. So what we're going to do is we're going to put clear value, 255, and then we're going to put 0 is 64. 1 is 121. It's from that chart. So take a minute and copy this down. So this is going to be our binary numbers we're going to send into the shift registers, okay? Let's see. This part you don't need to worry about right now, so let me get rid of this. All right. We're going to set up our pin modes. Again, you don't need to worry about this. Let's take that out. Okay. And what are we going to do? Well, the first thing we have to do is we have to turn our latch pin to low. So this says, all right, we could write some stuff in. Great. Then we could go ahead and we could shift out our number, our first byte. So let's go ahead and shift out our first byte. So that's going to look like that. That shifts out our first byte. So we're going to shift out a 0. We're going to shift out, you're going to say, okay, go to the data pin, set it with the clock pin, send out most significant bit first, and put it in 0. So that's going to go in 64, just like we saw in that chart. It's going to send this right here. Right like that. So 0, blah, 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 like that, okay? It's going to send that in. And let's play it. Well, first we have to just go ahead and say latch pin high to turn the lock back on. There you go. Easy enough. All right. Now, let's see here. Now, let's say we want to do another one. We want to do, whoops. Let's copy this one. And we're going to send in our second byte. This is going to be the register that's closest to us, closest to the Arduino. Let's not do 0 this time. Let's do 9. So what's happening is the first byte is getting sent over to this part of the Arduino, and then the second byte is getting sent here. If I had a third byte, not sure what would that do. I have no idea actually. Let's see who gets it. No one should get it because I don't have a third shift register. Let's experiment. I don't even know. Okay. So that's interesting. So what happens is the 0 gets sent out. Okay. Oops. The 0 gets sent out, and that gets sent out to the furthest one. Let me close this. Oops. Don't need the debugger right now. That's fine. So the 0 gets sent out to this one. And then the 9 gets sent out to this one. And then the 4 gets sent out. Well, this is going to overwrite this one. It's going to go over there. It's just going to shift. So we're going to end up with 0 is going to go out. 9 is going to go out to here. And then 4 is going to go out, which is going to kick this one over and push it there. So this will just kick it over. If it's already full, it just kicks it over to this one. If this one has something, it just gets erased. So that's the way that works. Hopefully you get how to do that. You wouldn't want to do this, so you just want to send like 2 at a time, right? Let's just say we do, I don't know. Let's do 25. So we'll send a 5 in, and then we'll send in 2. So you'll notice we'll have 25, right? Oh, wrong way. First byte has to get sent. 5 is going to be on the right. No, 25, good. Now let's say we want to do a little like delay. I don't know, 500. And then let's do this again. But this time, let's not do 25. Let's do like, I don't know, 92. Or, I don't know, 17. Let's do 17. So we'll go ahead and we'll send in a 7. And then a 1. And let's do a little delay. So now you'll get the numbers that are going to change, right? That could be like, whatever, your channel or what have you. Just so you get an idea of how the bytes get thrown in there. All right, that's all I wanted to cover in this video. So when I go into the next things, you kind of understand, what's going on and what's what. I'm going to have some questions with you for this, so just make sure you answer those questions.